All right, so today we're going to be working on the Unit 2 review. This is the review to get ready for the Unit 2 test. This review covers notes from section 3.1 to section 4.1. So when you're going through and doing problems from these and you're trying to look for extra practice, that would be the place that you would want to use to go back and look at your notes. As we do the problems in this section, you may want to go back and look at these to help you with each one as well. So question number 1 says, what is the third term of the sequence that's defined by the rule, and then you're given the function rule. So you want to make sure when you're doing this question that you see that it says the word third. So third means that you're looking for the third one, or number 3 in the list. So noticing that word would be pretty helpful. You can either highlight it or you can circle it. And then you're given the function rule. And so that's where you're going to be plugging in the number 3 to get your answer to the question. So to find the third number in the list, we're going to say f of 3 is equal to. So this 3 just means I'm plugging in a 3, and then I'm going to be plugging it in over here. Let me adjust the camera so it hopefully stops focusing on us. There we go. So negative 3 plus 5. Anytime you evaluate an expression or an equation, it's good to use parentheses. And then you're going to plug in whatever number this said. So it was the third term, so I would plug in the number 3. This part over here isn't going to simplify at all, so the f of 3 is always going to stay f of 3. And then 5 times 3 gives you 15. And then negative 3 plus 15 would give you positive 12. So this right here means that the third number in the list would be the number positive 12. This sequence, by the way, says you're starting at negative 3, and then you're adding 5 each time. And so if you added 3 5 times to negative 3, you would end up with 12. So that would be the third number in the list. Don't forget when you're doing this right here, maybe just make a note that you're going to follow the rules for PEMDAS. So parentheses, exponents, multiplication, division, and then addition, and finally subtraction. Question number 2 is kind of similar to question number 1. It wants you to figure out the value of f of x equals 3/5 x minus 2 when x equals 10. So it's not a sequence. It's still a function, but it's not talking about a list of numbers. It's just talking about an equation. But it's kind of the same thing. So x equals 10, and then this right here is your function rule. So that's what you're plugging it into. And so I'm going to do the same thing for this problem. They want to know, what do I get out from this when x equals 10? So remember, f of 10 just means that you're plugging in the number 10 equals 3/5, and then I'm plugging in the number 10 minus 2. There's a couple of different ways that you can deal with this fraction. We're not going to do fraction busters, because since we're not solving an equation, we're just evaluating an expression or an equation and getting an answer out for it. 3/5 times 10, there's a couple different ways that you could do it. Your teacher might have taught you to do top times top, and then divide by the bottom. So 3 times 10 is 30, and then 30 divided by 5 would be 6. You could come over here and do that work over to the side. Sometimes teachers will teach you to cross cancel. So 5 goes into 5 once, and 5 goes into 10 twice. And then 2 times 3 would also give you back 6. So it doesn't really matter the way that you do it. You do want to show a little bit of work when you're doing the question, though. Some people do 10 divided by 5 and get 2, and then do 2 times 3 and get 6. So no matter what you do to show your work for this, you're going to end up getting 6 as your answer. So f of 10 is equal to 6 minus 2. So f of 10 would be equal to 4. So again, this isn't talking about numbers in a list. It's talking about a function value, but it's saying when you plug in a 10 for this one, you get out the number 4. So again, these two questions are really similar to one another. You don't want to forget on both of them that you have to use PEMDAS to simplify. So remember the rules from PEMDAS from middle school. And then when you're showing your work for these problems, you're also making sure to show each step through. Your final answer is the number 12 on this one, but we write it this way. And then for this one, your final answer is the number 4, but we write it this way. It does say at the top of your paper, by the way, this is the review for the Unit 2 test. It says must show work to receive credit. So when I'm doing my work for number 3, this is a really tricky one to show work for, because you kind of just want to pick the answer. It's a multiple choice question. A bathtub is filled with 28 gallons of water. You pull the plug and it starts to drain. So the word drain right here means that it's going down. So it's going down by a certain amount. It's going down by 4 gallons every minute. So something about the 4 is going to be negative because it's going down by 4 gallons per minute. It says which function shows the amount of water that would be in the tub after t minutes. And so for some people, you can just look at it and figure out which one it is. I know there's going to be something about the 4 that's negative, so I'm guessing that it can't be B because B has a plus sign. But in order to show my work for this question, one way that you can show your work is you could make a little table. So if T stands for the amount of time, you can talk about the initial amount of water that was in the bathtub, how much water there was after 1 minute, how much water there was after 2 minutes, after 3 minutes, after 4 minutes, and then you could keep going. So at 0 minutes, it says it started with 28 gallons of water. And then it says that every minute that goes by, it goes down by 4. So after 1 minute, it would have 24. After another minute, it would have 20. After another minute, it would have 16. After another minute, it would have 12. And then it would keep going as you kept going down until it would eventually be empty. So part of what I'm trying to do is figure out which of these matches with this. We can eliminate B as an answer choice because we knew it needed to be something about subtracting that amount that was being taken away from each one. So it can't be B. And then it's going down by 4. So it's the 4 that we want to be negative. And so if we look at D right here, on this one, the 28 is negative and it's going up by 4. On this one, the 28 is positive and it's going down by 4. This function would be the function that if you plugged these numbers in, it would work for you. And so that's how you can decide that the correct answer is D. If you wanted to check 1 or 2 of these values to make sure that it worked, you could do that as well. So you could plug in the number 3. 4 times 3 is 12. 28 take away 12 would give you 16. And so you can check them to make sure that you're getting the right numbers in and putting the right numbers out. And so that's how you can help figure out which one's the answer to the question. So for question number 3, a table is a way that you can show work to get the answer to the question. Question number 4, it says which function situation would have a discrete graph? So a couple things to remember if it's talking about a discrete graph. On a discrete graph, it means I'm going to come down here on the bottom. So the points are not connected. Because only whole number inputs make sense. And your teacher might have not used the phrase make sense. Your teacher might have said something about existing or what the valid domain is or something like that. So it has to be talking about 2 variables where something's going in and something's going out, but only whole numbers make sense. So as we look through the list, B says the amount of water in a pool over a period of time. So for B, the water could go up over time when you fill the pool. It could go down over time due to evaporation or also to people playing in the pool and water splashes out. It's not only going down by whole numbers. It's not only going down by the number of gallons of water that's in the pool. It could be going down by half gallons as well. So since the in-between values make sense, we know that the answer for this question can't be B. So B doesn't make sense for it being discrete. If it was continuous, though, B could be continuous. C should say the amount. Sorry about that. Go on ahead and add that A in right there. C says the amount of detergent needed to clean clothes. So if your clothes aren't really that dirty, sometimes you can put in just a little bit of laundry soap. But if your clothes are really dirty, you want to put in more. But you're not just putting in whole number amounts of detergent because the cup that you use for laundry soap can be filled to different levels depending on how much you need. So for C, the in-between values do make sense. And so this would not be a discrete function because we need the in-between values to not make sense. So we're deciding between A and D, and this is where it gets a little bit tricky and you have to understand because students often use the phrase, can it be a half? So the number of people who attend a concert, you can't have half a person go to a concert or 2/3 of a person go to a concert. So some people might circle A as the answer to this question. But if you're just counting how many people go to a concert, there's not 2 variables involved in that situation. There's the concert and there's how many people who go. But this is just a count. This is just a number being measured. So it's sort of more like a total. On D, it says the cost of a number of shirts. So if you bought 1 shirt, it would cost so much. If you bought a second shirt, it would cost so much, and so on. And so for this one, you have 2 variables. You have the independent variable of the number of shirts you're buying, and then you have the dependent variable for the cost that they are. crop tops would be an argument against this, but you can't buy half a shirt. Like it's either a shirt or it's not a shirt. And so for that reason, we'll decide that D is the answer to this question because it compares two variables where the in-between values for the input don't make sense. You're buying full number shirts. And so that's how you can determine the answer to that question. All right, question number 5 says sketch a graph to match Melissa's situation. So there's going to be things happening on this graph. Let's break it into parts. So it says Melissa begins to run. So that'll be the first part. And it says then she slows to a walk. So that'll be the second part. Before taking a break, the break will be the third part. It says after her break, she begins running again. So she's not walking, she's running again at the end. So when I'm done with this graph, I don't know yet whether it's going to be straight lines or curves, but it's going to have 4 distinct pieces to it. And I'd recommend you label those while you're doing your work for this too. So it says she starts off running. We don't have numbers on our distance time graph, so we don't have to have the slope of the lines be perfectly exact or measured. But so if she's running, the line would be a little bit steeper. And so I'm going to label this 1 and say that this is where she's running on the graph. So that's the first part of my graph. It says she doesn't stop then, though. It says that she slows to a walk. So you walk generally slower than you run. So for part number 2 of the graph, this is where she's walking. It's still going up, but it's not going up as steep as the first part was. The third part of the graph says that she slows to a walk. So there should be a little curve right here. And then as she, the curve should have been right here. She slows to a walk before taking a break. So when she takes a break, this could be curved or not curved. But when she's taking a break, so part 3 is where she takes a break. Right here, time is passing, but the distance isn't changing because she's resting or getting a drink of water. So this should be a horizontal line. And then the fourth part of the graph says she begins running again. Now it doesn't say she's running back home. This is not distance from home, it's just distance. So when she starts running again, we're measuring her total distance. And so that's why the last part of this graph after the break is going to show that it's going back up. But it's going to be going back up like this part was because it's a run, not a walk. So it would be a steep incline, perhaps the same slope as the first one was, or perhaps slightly different. But so that would show you the different pieces of the graph. I recommend that you label each part with what's happening, and you can kind of match it up to the numbers inside the question. Question number 6 says, the graph shows Chad's distance from home over time. What's happening at the part of the graph that's labeled point B? So this is his distance, but it's his distance from home. So it's how far away he is from his house. So from here to here on A, he's getting further away from his house. And then from here to here on C, he's getting further away from his house. So we're trying to help answer the question about what happened at part B of the graph. So let's notice that part B of the graph started at the number 10, and part B of the graph finished at about the number 20. So whatever happened at part B took 10 minutes. And so when the time is changing and the distance is not, it means that it's taking a break. So the person stopped moving. We don't know what they were doing when they stopped moving. Maybe they had to use the restroom. Maybe they ran into a store to grab a snack, something like that. Maybe someone called them and they stopped to talk to them, or they found a friend and they stopped to talk to them. But so from here to here at B, Chad stopped to take a 10-minute break. And you can be creative, appropriately creative, with the things that you decide to write as his example to the question. It is helpful to indicate the length of the break. So if this axis right here is, if it has numbers on it, then you can give more specific information. Whereas if it was a graph like this, we don't know exactly how long Melissa's break was in this situation because this axis wasn't scaled. It didn't have numbers on it. This axis had numbers on it. And so that gives you a way to do that too. Question number 7, the last one on this page, goes back, and it's sort of like the 2 of these that we started with. So remember, I had a function. I was trying to find the third number in the list for the function rule for the sequence, and so I plugged in the 3. On this one, I was trying to figure out when x equals 10, what was this equal to? And so for this one, I'm also going to have to be careful for PEMDAS. I'm given a function rule, and then I'm asked to figure out what's f of negative 4. So I start with the same process. So f of negative 4 is equal to, and then I'm going to go through and I'm going to be plugging the negative 4 in, but see how there's an x here and there's another x here. So I have to put the negative 4 in for the first one. Anytime you evaluate an expression, you take out everywhere you see the letter, and that's where you put parentheses for where you're putting the new number in. So I took out the x here and I put a -4 here. It still has the squared though. And then I took out the x here and I put the -4 in here, and so that's that one right there. Make the note again that you want to be careful that while you're doing this, you follow the rules for PEMDAS. And this one's going to be especially important because there's some negatives, so you're going to have to be careful with that. F of -4 is equal to, okay, -4 squared gives me +16. -3 times -4 gives me +12. And then the +2 just stays +2 on the end. So again, this turned into +16 because it means you're multiplying -4 by itself. So -4 times -4 is +16. And then -3 times -4 gave me +12. And then the +2 stayed +2. So to find my answer to this question, all I have to do is add up the numbers in the list. So 16 plus 12 gives me 28. And then 28 plus 2 gives me 30. So question 1, question 2, and question 7 were asking me to do the same thing on all of the problems. I was plugging in a number, and then I was following PEMDAS to simplify. So on page 2 of your review, it starts out with a question that says, what is the domain of the relation shown on the mapping diagram? So a mapping diagram right here is the one that has the circles on it. It has numbers that are written over here on the left and then numbers that are written over here on the right. The arrows connect the numbers that go together. So 8 goes with -1, 9 goes with -3, 10 also goes with -1, and then 13 goes with +5. So the arrows show you how they connect together with each other. Make a note on your paper that the circle on the left or the oval on the left is always the domain, and then the one on the right over here, that one's always the range. So this question doesn't want you to list off both of them. It just wants you to list the domain. So we're just going to write down over here that the domain of this function, and again, these numbers are generally written from smallest to biggest. Even if they weren't written from smallest to biggest over here, you would want to write them from smallest to biggest in your list. So the domain for this function would be 8, 9, 10, and 13. If there wouldn't be doubles in a mapping diagram, because in a mapping you take out the doubles, but if you were doing this from a table of values, and if there were two numbers that were doubled up, you would only list them once. It's helpful to point out that if it wanted you to list the range would normally be given in order. So -3 would go first, -1 would go second, and then 5 would go third. But it doesn't want me to list the range, so I'm going to go ahead and only list the part of the question that it's asking me to answer. You want to make sure that you don't write down both of them, because then your teacher might not know that you know which one's which. Also notice that I labeled this with D so that it was evident that I was finding the domain. In question number 9, it says, is the relation shown on the table a function, and explain how you know? So the explain how you know part is probably, there's two questions that this is asking. The explain how you know part's a little bit more difficult. So part 1 says, is it a function? So that's going to be a yes or no question. And then part 2 says you're going to explain how you know. So -2 gets matched up with -5. -1 gets matched up with -4. 0 gets matched up with -3. And then 1 gets matched up with -2. And so there's a couple different ways that you can help yourself decide that the answer to this question is yes. None of the x's in the table repeat. So all of the x's in the table are different. So that's one way that you can help yourself know if it's a function. Generally speaking, most teachers won't take that as a description though, but if you didn't know what to write, you could say none of the x's repeat in the table, and you might get partial credit for the question. The reason why it's a function though is because each x is paired with a different y. There's not an x that goes to two different y's at the same time. So each x is paired with its own y. Each x is paired with only one y. So we can say each x value, or you could use the word domain here as well, because that means x value, is paired with exactly one range value. So each number in the domain, or each element in the x list, is paired up with exactly one range value or y value. So there's no x that goes to two different y's. If there was a double x, so if there was one here and one here, and if the same x was listed twice going to two different y's, then the answer to this question, instead of being yes, it would be no. So practice the different ways that you can word this. Ask your teacher if there's a special way that they want this one worded to get the answer to the question. Question number 10. Sam is collecting water bottles to recycle. His neighbor gives him 38 bottles, and then each week after he collects 18 bottles around the neighborhood. So that's giving you information about the problem. So it says his neighbor gives him 38 bottles to start. And then it says that each week after, and that's important, the words each week, he collects 18 bottles each week after. So he starts with 38, and then it's going up by 18. The directions for this function say to write a function, so that's how you know you're going to start with the letter F, to show the number of bottles that he has after W weeks. So I'm not going to use X and Y for this problem. I'm going to use W, and I'm going to use F of W to write my answer to the question. There's two ways that you could write an answer to this question. So as a function of weeks, he starts with 38 bottles, and then he adds 18 each week. Notice that I'm using the letter W instead of the letter X because it told me I was talking about weeks. You could use the letter X if you wanted to, but sometimes people prefer to use a letter that corresponds to whatever that independent variable is. The other way that you could write your answer to this question is you could say F of W is equal to, and so you could flip it around and put the 18W first. Notice that both of the ways that I wrote my answer to this question, it didn't matter which way I wrote it though. The W stayed with the 18 and the W stayed with the 18, and that's because this had the word each with it. So each week means that it's every week that it's changing. And so that's why here and then down here in this one, the W has to go with the 18 because it's the number of weeks that pass that change how many bottles he has. Question number 11 says to graph the function, and you're given a function right here. And it says we're going to graph it for the domain, and then a domain is given to us. Whenever a domain is given to you, it means that those are the numbers that you're going to plug in, but those are the only numbers that you're going to plug in. So first things first, it might be helpful for you to be able to do less work later to manipulate this equation to get the y all by itself. So if you get the y all by itself, it makes it easier to plug in the x's. If I minus the 3x from both sides, I get negative y is equal to negative 3x plus 4. You could also write this the other way if you wanted to. So it would be okay to write it as 4 minus 3x. You would get the same answer to the question. And then to finish, I would have to divide everything by negative 1 because remember, I'm trying to get the y all by itself. And so when I write that as an equation, that equation becomes positive y equals positive 3x because negative 3 divided by negative 1 is positive 3. And then positive 4 divided by negative 1 is negative 4. So y equals 3x minus 4 is what the equation turns into. So that doesn't tell us what these numbers are going to be. We still have to plug in the numbers to figure out what numbers we get out for our y's. So there's a couple different ways that you could do this and show the work for it. It's kind of crammed to show all of the work in here. So what I'm going to do is I'm going to make the table over here, but then I'm going to show some of my work over here off to the other side. So here's my x's and here's my y's. I'm going to plug in a negative 2, I'm going to plug in a 0, I'm going to plug in a 1, and I'm going to plug in a 4. And I'm plugging them into this equation right here. So all of the numbers for my x, I'm going to plug in one at a time right there. And I'll do the work for that over here. So 3 times negative 2 minus 4 turns into negative 6 minus 4, which gives me negative 10 when I combine those. So negative 2 goes with negative 10. You could do the work for this part on your calculator, but just make sure that you show your work somewhere. 3 times 0 minus 4 turns into 0 minus 4, which is negative 4. 3 times 1 minus 4 turns into 3 minus 4, which is negative 1. And then the last one, 3 times 4 minus 4 turns into 12 minus 4, which is positive 8. So when I plug in the numbers negative 2, 0, 1, and 4, I get out the numbers negative 10, negative 4, negative 1, and positive 8. These are my domain values. These are my range values. The domain values were provided to me, so these are the only numbers that I'm going to graph. It also means that I am not going to draw a line through these points. Even though they're going to be in a line, I'm not going to draw a line. Do not draw the line. So they will be in a line, but I'm not going to draw the line when I graph them. Negative 2 goes with negative 10. 0 goes with negative 4. Positive 1 goes with negative 1, and then 4 goes with positive 8. So based on the limited domain that I was given, those are the values that I would get out. The last part of this question that's kind of hidden down here says, is the function discrete or continuous? So that's a yes or a no question. And then the second part says that it wants you to explain why. And so don't forget to do that part too. So discrete or continuous means, did you connect the points or did you not connect the points? Discrete means that the points are not connected. And continuous means that the points are connected. And so on this graph, we've already talked about it, but so we're not going to connect the points on this graph because the domain was provided to us. This graph is discrete, so that answers the first part of the question, but the reason why it's discrete is not because the points are in a line. The reason that it's discrete is because the domain was provided to you or given to you in list format. So the domain was provided or given in a list, and sometimes we call that set notation. And so because the domain was given to you as a list, it doesn't matter whether they're in a single line or not. This means that it's going to be discrete. So being in a line does not make the graph continuous. A lot of people, when they're trying to decide if something is going to be discrete or continuous, a lot of people just want to look at the line and they say, oh yeah, you can put a line through it, so it must be continuous. But it would only be continuous if we were given the function without this list of numbers. So anytime your domain is given to you, it's always going to be a discrete function because you're only graphing it for those particular set of points. Question number 12 is another practice problem that just says find the domain and range. Remember, in a set of ordered pairs, the number ordered pairs are separated by the parentheses. So this one's your x, and this one's your y, this one's your x, this one's your y, x and y, and x and y. So the x's always come first in the ordered pair, and the range always, or the y always comes second. So it says we're going to find the domain, and it says we're going to find the range. And it is asking us to find both parts on this one. So when you make your list, make sure that you label which one is which. Domain and range are given as a set. A couple of reminders. The domain is my x's, so my numbers are 1, or let me start at the beginning. So 2, 4, 1, and 2. My smallest domain, or my smallest x value, is the number 1. And then I've got the 2 and the 2, and then the 4. So when I do my domain, I'm only looking at the x's. Let me highlight those. So my domain will be yellow. So when I do my domain, I'm only looking at those numbers. There's 2 x's that double up. When I write them in order from smallest to greatest. And then the one that doubled, there were 2 2's in the list, but I only write it once. So make a note of that as well. When I list my range value are the y coordinates of the points. So it's 6 and 3, 3 and 6, 5 and 5. But again, when I write this down, I'm going to do it from smallest to greatest. So 3, 5, 6. And then even though there's 2 y's, I'm only going to write the range value 5 once because you don't write down repeats. Don't double the repeats, so you only write them once. Notes like that on your review will be helpful because when you look them over before the test, any little words or phrases that you write down will help you hopefully remember them right before the test. All right, question number 13. It says graph the function y equals 2/3 x minus 1. So when I'm graphing this function, there's a couple of different ways that I can do the work to graph this function. The most common way of doing the work for this would be by making a table. Since my space here is horizontal, I'm going to make my table go from left to right. So I'm going to plug in x's, and then I'll get out y's for my answer. You want to make sure you plug in a couple points. Some teachers say that 5 is a good number to stick with. It just depends on what you want to do. You want to make sure that you show work for the question as you're going through and plugging numbers in. Now notice that 2/3 is a fraction and the bottom number is the number 3. So sometimes when you're picking numbers for a table, you just pick -2, -1, 0, 1, and 2, but it's different if the bottom of the fraction is a number like the number 3. I'm going to pick the numbers -6, -3, 0, 3, and 6. And so I'm always going to pick 0. That's just one of the x's that I'll always pick. But I'm picking y's that are going to be easier to times by this because the 3 will cancel with these numbers. So if this were a 2 on the bottom, I would pick -4, -2, 0, 2, and 4. So I'm always picking what the bottom part is right here. I'm going to be a little bit crammed in terms of showing work, but I should be fine. 2/3 times -6 minus 1. You want to be careful with this. 3 goes into 6 twice, and then 2 times 2 is 4, but there's a negative right here. So that turns into -4. Don't be afraid on the test to clarify that that's correct by typing that into your calculator. You can always type this into your calculator to make sure that you're getting it right. 3 divided by 3, or 3 goes into 3 once, so -1 times 2 is -2, and then -2 minus 1 is -3. 0 minus 1 is -1. And then let's see, I think I should be able to fit my work for the other two just over here because I have a second question for this one to answer right here. So 2/3 times +3, take away 1. 3 goes into 3 once, and then 1 times 2 is 2. So this one goes with +1. And then the last number I picked was the number 6. So 2/3 times 6 minus 1. 3 goes into 6 twice. 2 times 2 is 4. And 4 minus 1 gives you 3. So this question right here is different than this question was down here. On question number 11, I was given 4 domain values, and I was told to only graph it for this given domain. That's why this was a discrete graph, and that's why even though it was in a straight line, I didn't draw the straight line because the numbers that I was given were the only numbers that I was provided for the function. When you do this next question that we're on right now, though, you are going to draw a line. Make sure that you have a ruler or something that you can use to have that line be straight. This is a linear function, y equals 2/3 x minus 1. The first point is at -6, -5. The next point is at -3, -3. I have a point at 0, -1, 3, +1, and then my last point is at 6, +3. And it's good that those ended up being in a straight line because they're supposed to be. On this one, you were not given these 5 numbers. You picked whatever 5 numbers that you wanted to. And so you make a note on this one that this graph is continuous. It's not continuous because it's in a straight line. It's continuous because there could be in-between values, and in fact there are. There's all numbers in between here and here and here. So it's continuous because the in-between numbers make sense, and so that means that once you graph it, you're going to draw the line. So 11 and 13 are different in that regard. And so that would be the graph of that function. You do want to make sure that you draw the line on this one. Question number 14 says to create a mapping diagram. And so you want to be careful with the way that you set this up. Usually in a mapping diagram, it goes from smallest to biggest. And so my x's, I'll use the same colors as before. So 2, 3, 1, and 2, those are going to be my x's. So x is going to go 1, 2, 3, because remember, you usually do it from smallest to biggest. And then for my y's, I have 3, 5, 2, and 4. So when I do my y values, I'm going to go 2, 3, 4, and 5. So smallest to biggest, or least to greatest. And then when I do my mapping diagram, I'm drawing the x's and I'm showing how they connect to the y's. So 2 went with, I do them in order. So 2 went with 3, so that one gets an arrow. And so the arrow starts from the domain and goes to the range. 3 goes with 5, so it starts from the domain and goes to the range. 1 goes with 2, and then 2 goes also with 4. So you make sure that if you started with 4 points, there should be 4 arrows drawn on your graph. And the last part to this question wants us to decide, is the relation above a function, and it wants you to explain. Doing this from a mapping diagram can sometimes be hard, but the number 2 is the number that helps you decide that the answer to this question is no. It is not a function. And then we're going to have to also explain why. So don't forget, I'm trying to highlight this in the review so that you don't forget that you have to explain. On the test, you'll get points for explaining this in the correct words. So no, it is not a function. That's the first part of the question. But then you have to do a good job explaining why. Because the input x equals 2 is paired with and then there's a couple different ways that you could word this. You could say that it's paired with two different y values. You could say that it's paired with two different range values. You could say that it's paired with y equals 3 and it's paired with y equals 4. There's lots of different ways that this could be worded, so don't worry about memorizing my way. Just make sure that when you're doing it, you pick a way. You could say there is a x in the list that goes to two different y's, and so that would be another way that you could word this. You could say 2 goes to 3 and 2 goes to 4, so that's bad. That's another way that you could word it. Just keep in mind, though, if you could say the 2 repeats up here, and so you know that's bad. If there were more x's than y's, and if there was an x that went here, and then if there was another x that went here, it's okay if different x's go to the same y, but it's not okay if one x goes to two different y's. Let's write that down. So it's not okay if one x goes to two different y's or y values. And so that gives you kind of a little bit of a reminder about how that's going to work. The last question on the review today says use the vertical line test to determine if each of the following relations is a function. So you're determining if it says determine if, that means your answer to the question is going to either be yes or your answer to the question is going to be no. Right away I can tell that A is not a function because any vertical line that I draw on the graph could cross this shape at two different points. And so for this one, the answer to the question is no, it's not a function because it fails the vertical line test. If the vertical line passes through 2 points of the graph, and by the way, you could draw this line in the middle or you could draw it over here, it doesn't matter, just make sure that you draw one somewhere on your test. We say that it fails the vertical line test and it's not a function. On this last problem, on example 15b, if you drew a line here, you're all set. If you drew a line here, you're all set because each of these just cross once. You're okay here, you're okay here, you're okay here. Anywhere you draw a line, anywhere on this function, it only crosses the curved line one place, one place, one place. And so it doesn't matter where you draw it. It kind of looks like you're shading it in, right? But so it doesn't matter where you draw it. It never crosses it in more than one spot. So for this one, we would say, yes, it is a function. And we can say the reason why it's a function is because it passes the vertical line test. And so it passes if it only hits once, and it fails if it hits twice. So having it hit twice isn't necessarily a bad thing. It doesn't mean this graph isn't as good as this graph, but when it crosses twice, it means it's not a function. So this one's not a function, and this one is a function. And so that's how you can tell the difference between whether something is a function or whether something's not a function just by looking at the graph. So you wouldn't necessarily need an equation, a mapping diagram, a table, or a set of ordered pairs to answer that question there.